Greetings and welcome to another episode of Alfredo's Code Along. This time, I am going to teach you a little bit about how to make a visualization tool framework for a sorting algorithm. I've been using Godot engine for a lot of visualization tasks and projects, including but not limited to data and algorithms as such, and I find it rather convenient, so I'm here to share a little bit of my process of the project. So the project itself is recorded previously because I broke the audio, so everything audio related is redubbed. Alright, we just start with an empty project, start with an empty node because of my habit to have a main node that contains everything else. And just because of personal preference, I'm changing the viewport size to 1080p. You can change that to whatever you'd like. Okay. Now we just add a black background because all of the algorithm visualization, especially the sorting ones you've seen, usually have one of these, and it looks cooler and saves my vision, so I'm going to do that as well. Okay, now we have the black background, we save the scene, and we just go to a new scene and create a UI. We're going to use a UI node actually. Okay, we use a user interface. This is the framework where we're going to put our visualization. Let's call it sort visual. Okay, and then we add a, I believe, H bar separator or container. So instead of making everything from ground up, we're going to use HBox container. We're going to use the Godot feature that really conveniences us in terms of making what we want. Right, the convenience part about HBox container is it separates the content inside of it horizontally and evenly, if you set it as such. So it makes things very convenient for us. Okay, so we center it. Just follow the steps here if you don't really understand the UI elements. If you do, you can create your own. Alright, so inside the HBox container, we're going to represent the data of an array. If you're doing a sorting algorithm, we're just going to represent it with the height of various rectangles. So we're just going to use a flat color rectangle, and since we want to adjust its height, right, to the value of the array, we're going to change the vertical to shrink end so that it can be adjusted, but the horizontal can be filled because however many of these bars, right, these color rectangles we create, as you see on there, we duplicate it with Control D. You can see that it starts to form the base of a sorting algorithm visualizer we have. Okay, now we can delete the x-axis ones and make sure to change the vertical transform to shrink end. Okay, so with changing custom minimum height Y, I believe, you can change the height as I'm shown here. So whenever we link this to the array values, the number or integer values in the sorting array, it will in real time display the value of the data, which is exactly what we want. Now let's just make this bar a separate scene so we can instantiate later to create those individual bars. Okay, also saving this scene, and then we can start making our scripts. Alright, we don't need this anymore since we're going to be programmatically creating them. We also make a bar script in case we need to save a few values, basically treating this as a separate class. Okay, so what we need is an index. This will be used in the scene tree to rearrange those bars when we are visualizing the sorting algorithm. Right, as well as a value. This understandably is correlating to the value of your number that is sorting in the array. Okay. Now let's start making the actual script for the sorting visual. Go to the base node, create a script, attach a script onto it, and let's start making what we need. First, the exports, the onreadies, the start you need to get ready before things starts. Okay, so first the onready bar, we are going to preload the scene we just created, the bar scene. Okay, and then we will need to prepare a few variables. We also want, obviously, a pointer to the container, which we just call a graph container. Okay, we are going to be adding these bar effectively onto this into this container like a tree. Okay, then adding a few variables for the arrays we're actually going to sort and the arrays we're going to create. So let's create an array to sort. This is the array that we're going to save all of these bar scenes, the visualization scenes. And then we're going to need a num array. I just like to separate them. You can technically make them the same one. So this num array is basically a randomized array of elements that's random integers or floats, so whatever floats your boat, I suppose. So this is the array we're sorting. Let's create it. It's just going to be a very simple array that's randomized. We're going to give it a few parameters just to make sure we can create different length. This can be used as an animation tool, so make sure it has ability to be, well, changed, I suppose. So we're going to change it depending on the length. The minimum value of the array and the maximum value of the array is going to be an integer array, but you can obviously change it to whatever you'd like. So first we initialize the array to, well, a blank array, and then we create a list of ordered arrays going from actually I changed this array a little bit, because at first I was going to completely make the array random, but for the sake of visualization and make it pretty, I made it just to be the length of the array, and every block of the value is going to be one off, so it looks like a very ordered stair, right? So basically right here I'm just creating an array by putting ordered elements back to back, and then just reshuffle the array so it is unsorted. Right, then we're going to basically reverse the process, sort this array. Right, now let's see if we made this array properly. We're going to create an array of, well, 20 elements. So for this specific version I made here, you can ignore the min and max. This is in case you want to randomize and set the limits of the values. Okay, we're going to need a max value here, just so we can normalize the array values right onto the graph. So the maximum value of the array, we want to normalize that to the maximum height of the container we have. Which there is a very simple conversion. I think I did it in a line right here. Every time we add a value to this visualization array, we're going to call a function, let's name it add bars. Right? Every time we see a value in the num array, which is just a number, we are going to add a bar that represents this data value. And we'll do that in the function I'm going to be doing right now, I think. So this little line of equation is just normalizing the values. So basically the I values in num array is just a number, dividing by the max of it and multiply by the height. Right, the size, the height of the container, the graph container, is going to mean that the highest value in this num array is now the height of this container, and the lowest value is obviously as close to 0 as it can be. Okay, so now let's make the add bar function. The only thing we need in there is the height of the values, basically representing the value of the array, value in the array, array element, I suppose. So this is the standard steps to instantiate new scenes, right? So we create a new scene, we link the value of the bar to the height, right? And then we will go to add this new scene into the array to sort array. Okay, then we are going to add this array, or sorry, this new bar as the child of the graph container. So it's added into the scene and it will be displayed. And lastly, we set the index of the bar to the index of this child element within the scene tree under this graph container. This is how we're going to adjust the order of these visualization elements, these bars, depending on or when we sort it, right? When we sort the elements in the array. So let's run it and see what we have. Well, obviously I made a few mistakes right here, I think. I forgot to add the UI to the main scene. Right. Now if we run it, still have nothing. I obviously missed something else. Let's see what I missed here. Oh, of course, because I did not set the bar's height value yet. So I only set the value, which is just a variable for the bar class object. All right, we need to actually set the height so the visualization elements are updated. So let's create a set height function that when we call it, it's going to update the bar's height, which is the, I believe, the custom minimum size y, and we set that to the value that we set earlier. Okay, now we just need to call it in the add bar function. Set height. Okay, and I believe this should work. Okay, now we have a visualization of the array elements. Right? The individual array elements of, I believe, 20 values here, and they are now displayed as the height of some good-looking graph. All right, now that we have the array, we're going to need to start sorting it. Right? This is the sorting element visualizer, sorting algorithm visualizer. In order to do that, we need to do a few things. First, let's make a button that does things when we click it. I usually like to have some sort of activation that helps me debug things easier. Usually I just set it to some sort of keybind, but in order, for the purpose of the video, I'm going to have a button so that you know when I'm clicking things. Okay, so right now inside this scene tree is what's going on. We instantiated many child scenes of the bar under the graph container. These are the individual white bars. Right, all of the order is indicated by the index of these child, and these index we've saved to, well, index, and we can manipulate it by changing the index effectively. So right now I'm going to make a quick few lines of test code to see if I can actually switch those around. All right, for example, if I'd like to switch the first two elements of the array and make sure it's reflected in the visualization, well, I do a very simple switcheroo. You can do it in, I believe, 3 lines code, but I'm just writing everything out here just to be clear. Right, so we save the first two array elements to two variables, one named first, one named second, and then we will trade the index of these two values, right? Change the first index to 1, second index to 0. Remember, it starts with 0. And then we will put those elements, switch these elements around in the array to sort. Okay, I believe I made a small mistake here. I forgot to change the 0 to 1 when I copied it over. Make sure whenever you're copying code, make sure you are very careful. Okay, this is the part where we actually move the child. Right? It's the move child function. Oh, and then we are going to need a function that just tells us to update the visualization, which is the scene tree. So basically we're looping through the entire array to sort, check every individual elements in there, and arrange them depending on the index we set them into. Right, it's a very simple one. And you can see right here how I do it. Move child basically takes the I as the array elements and then set it to a certain index. Okay. So when I click test, these two array values are now swapped. There's a minor mistake here. The array to sort should be well, 0 and 1. Right, or sorry, 1 or 0. No, 0 and 1. I changed it later on in the code, but right now this is a slight mistake. Just to make sure you know that something's wrong with this. Okay, so now that we have ability to switch elements around and we have a basic foundation, let's make the actual sorting algorithm. So I'm just using a very simple, easy to implement basic sorting algorithm, bubble sort. And this is basically just a Python implementation. I changed it easily to the gdscript. If you don't know much about sorting algorithm, there are many better tutorials that actually explains it better than I do, so I recommend you go watch those first before coming back here. Just to give you a very simple explanation, bubble sort is basically going from start to finish in an array, checking neighboring elements to see which one's bigger. If they're bigger ones, if we're going from left to right in an array, for example, if the value in the right is larger than the value in the left, you do nothing. If the value on the right is smaller, you switch these elements around. It's a simple double loop structure. Okay, so this is just going to be a very quick implementation. Okay, right now we're just putting the if statements, if the values right on the left is larger than the value on the right, which is not the order we'd like, then we switch it. Okay, so we'll just do a value comparison. And in here, we're going to swap these values around. Right. So the swap function, we basically made it in the on press. Okay, and here we have the stopping condition. Okay, let's make the swap function here. Instead of just switching the first two elements, we're going to take in parameters of the first and second elements we'd like to switch, and then we'll switch those. Keep in mind here I'm using the indexed. These are not objects. These are the indexed of the array elements you'd like to switch. Okay, so you can see right here, I'm changing these values and renaming the variables. You can probably come up with a better way to rename things. Basically, two temporary elements, saving the first and second array elements we'd like to switch. Once again, remember the first and second here are using the index. Or index of the array elements, not the index of individual bars. I know it's a little confusing, but take a moment here to figure out what each variable and each term means. Okay, and we once again swap the index, and then swap the array elements. Okay. that is the swap function done. Now let's make sure we add an end condition, exit condition. If we go through the entire array and nothing has been swapped, that means everything is now in order, and then we can exit the element. Or exit the function. Okay, if nothing has been swapped for the entire run, if it's false, then we just break. Okay, now that's the whole thing basically done. So we're going to let the function to be called when the button is pressed. And we're going to call the bubble sort. But right now, when you click it, well, nothing happens because I forgot to update the scene tree here. The values in the arrays are sorted, but the scene tree has not been updated to reflect it. So at the end of the sort, let's just call the update scene tree, and now we should see everything being sorted perfectly. Okay, it looks pretty good. However, this is a visualizer, right? We know that it works. Great, good for debugging. But it'd be cooler if we can see the individual elements move in real time. All right, so let's just add in a few displays and a few delays, perhaps, so that our human eyes can figure out things faster. The computer does things extremely fast. The sorting algorithms are going to do things in a split second. So in order for us to see what is going on inside, we have to update the scene every time something happens and put a certain delay in it so that we can see. Okay, I believe this part is a little slow. I'm going to move it a little bit. Okay, so we're going to add in a timer. This is basically making a timer in code and let it have a slight bit of delay for 1 second, and then we update a scene tree to let it reflect what's going on, right? I think I switched it to after swap. Okay, right now we already see something's going on, right? It looks like it is moving. I think that pretty accurately reflects the algorithm. You might notice the last bit is not upgraded because we forgot to update the scene at the very end. So right now I think it should work properly as expected. Okay, this is quite pleasant to watch, and I highly recommend making one of these if you're just starting programming, starting to learn algorithms at least. Okay, so right now it looks pretty cool already. Things are moving, but it would be cooler, and a lot of algorithm visualizers do this. Add some colors into it. I will be honest, I don't really remember what I was doing here. I think I'm adding colors. Yes, so we're going to display the current 2 bars are being checked and being swapped. So we basically add in a variable that saves the 2 bars that are being swapped, initialize it to the first and second. But obviously we just call it here. Or we just change this here. Alright, so we're going to set the color, initialize the color basically to white. Right now, we just want to make sure nothing is going on. And then we set the 2 current bars to be the 2 we're checking right now, the array J and array J plus 1. Okay, and then we just highlight these 2. And we're just going to highlight it with the color green. Okay, it should be pretty standing out. And at the very end, just clear these colors. Make sure they're not like lingering at the end. I think that should work. Okay, there is a little bit of offset. That's because I did things in a slightly incorrect order. I think I'll be saving it or changing it very soon. I believe the fix is simply putting it after the await, or the swap, sorry. Okay, looks like it's been fixed. Just to give you a quick pause to what the correct value is. Well, all of the code will be uploaded to GitHub, so if you want to see the end result as a reference, you can go there and check it. Okay, these are basically the current two values are being checked, and you can see every time if the right one is smaller than the left, they will be switched. And let's speed it up. We now have a rapidly sorted array. Looks pretty cool, right? So there is an issue. So when we want to increase element, I promise this to be scalable. Right? We can increase the elements in the array. This becomes rather slow. Obviously, there's many more values are switching over, but you can't simply increase the speed by decreasing the timer, because the Godot engine has a limit on the timer that I believe the smallest time increment that will have any effect is linked to your FPS, your physical process frames, which I believe right here is set to something like 60 frames per second. So anytime below that is not going to be reflected. But what we can do is to artificially skip frames, right, with a counter. So basically, we're going to display this thing every 5 or 6 comparisons, right? And visually, the effect of it is that the speed of the algorithm has increased by 5 times. Our human's eye can't really catch anything below 0.1 seconds, or 0.01 seconds, I believe. So this doesn't really matter. It makes a cool looking animation, right? What I'm doing here, basically, if the counter is a multiple of 5, it's going to actually pause for a short minute and update the scene tree. And you'd see something like this. This is the end result. Okay, and you can increase the speed obviously by decreasing or increasing the frame skips. And we also notice that each bar has a very noticeable gap between them. That's because the default value in the graph container it has a separation. You have to turn on an override to turn off that separation. I like the look of it when there's no separations, especially when there's more elements. But maybe if you have less elements, it'll look better without or with a separation. That's up to you. It's your preference. Okay. So now we have a pretty good looking sorting algorithm of a bubble sort. It is one of the simplest sorting algorithm, but it creates a pretty mesmerizing visual regardless. Okay, this is a scalable and workable foundation for many other things. I'll prove it to you. So you can basically adjust the size of the container however you'd like, and this visual will change. You can make animations on top of it, moving around, adjust or manipulating the container location and size. You can add your own text to the side as well. I also made a working quick sort visual. Just quickly made the algorithms and to test if everything works. So as you can see, it works pretty well, and you do have to minorly change the display code in order to achieve whatever your sorting algorithm specifically requires. But I can guarantee you that this setup works for everything. Okay. All right, and that is it for today. Thanks for watching.